Chapter 7, Functional Groups, Class Life Sciences. Part 1, Families in Organic Chemistry, Isomerism. At the end of this session, students should be able to classify organic compounds into families based on their functional groups. Identify the functional groups. Recognize skeletal, positional, and functional isomers. Introduction. Organic compounds are chemical compounds that contain carbon and hydrogen elements, mainly carbon. The molecules of some organic compounds are characterized by the presence of particular group of atoms called functional groups. The functional group characterizes the organic compound and gives its chemical characteristics. According to the nature of the functional group, organic compounds are classified into families. 1. Families of organic compounds. Part 1, first family, alcohols. Of general formula, ROH, functional group OH, which is called hydroxyl group. Example, CH3CH2OH, ethanol. This is the model of ethanol. CH3, C single bond C, H2OH. OH is the functional group of alcohol, which is called hydroxyl group. Second family, ethyl, of general formula, ROR prime. Instead of hydrogen in case of alcohol, we have alkyl group. Then the family becomes ethyl. The functional group is the oxygen atom, which is the ethyl group. Oxygen atom bonded to two alkyl group. Carbon in this bond and carbon in this bond. Example, CH3O CH3 dimethyl ether. This is the 3D model of dimethyl ether. CH3 single bond O single bond CH3. Third family, aldehydes. General formula, RC double bond O single bond H or RCHO. Functional group, C double bond O, which is called carbonyl group. Example, CH3CHO or C double bond O single bond H, ethanol. This is the 3D model of ethanol. CH3 single bond C, double bond O, single bond H. This is the functional group. This is the functional group, C double bond O, carbonyl group. When carbonyl group is bonded, when the C double bond O is bonded to hydrogen atom, then the compound belongs to family of aldehydes. Fourth family, ketones. General formula, RC double bond O R prime or RCOR prime. Functional group is also C double bond O, which is a carbonyl group. But in this case, the carbonyl group, the carbon of the carbonyl group is bonded to two carbon in each side, carbon this side and carbon in the other side. Example, CH3 COCH3 propanone or acetone. This is the 3D model of propanone, CH3, C double bond O, CH3. The functional group, carbonyl group, C double bond O. The carbon of the functional group is bonded to carbon from one side and carbon from the other side. Carboxylic acid, general formula RC double bond O single bond OH or RCOOH. Functional group C double bond O single bond H or COH, which is called carboxyl group. Example, CH3COH, ethanoic acid. This is the 3D model of ethanoic acid, CH3, C double bond O, single bond OH. Then this is CH3, single bond, C double bond O, single bond OH. This is the carboxyl group, the characteristic group of the carboxylic acid. Esters of general formula RC double bond O R prime or RCOO R prime. Same as carboxylic acid, but we replace the hydrogen atom with alkyl group. Functional group is C double bond O single bond O or COO, which is called ester group. Example, CH3COO CH3 methyl ethanoate. This is the 3D model of methyl ethanoate. CH3, CH3, single bond C double bond O, C single bond O, CH3. This is the ester group, which is C double bond O, C single bond O. Seventh family, acyl chloride, general formula RCOCl or RCOCl. Functional group C double bond O single bond Cl or COCl, which is called acyl chloride group. Example, CH3COCl ethanoyl chloride. This is the 3D model of ethanoyl chloride. We have CH3, C double bond OCl. This is the functional group C double bond O single bond Cl, the acyl chloride group. Acid anhydride, general formula R C double bond O O C double bond O R or R or R prime, RCOO R prime. Functional group C double bond O single bond O single bond C double bond O or COO acid anhydride group. Example, CH3 COOCOCHE ethanoic anhydride. This is the 3D model of ethanoic anhydride. CH3 C double bond O C double bond O CH3. This is the functional group C double bond O C double bond O, the functional group of acid anhydride. Amine, general formula RNH2 R1 or R1NH2 or R1N2R3. Nitrogen atom bonded at least to one alkyl group, may be bonded to two alkyl group or three alkyl groups. Functional group is the nitrogen atom with its three bonds, at least with one with carbon, one of them with carbon atoms, which is called amine group. Example, CH3NH dimethyl amine, and this is the 3D model of dimethyl amine, CH3NH. N is the amine group. The last family is the amide. General formula RC double bond O single bond N R prime R2. R prime and R2 could be hydrogen or carbon and hydrogen. Functional group C double bond O single bond N with two bonds. which is called amide group. Example, CH3, C double bond O, and H2. In this case, R prime and R double prime are hydrogen atoms. This is which is called ethane amide. This is the 3D model of ethane amide. We have CH3, C double bond O, C single bond N, H2. The red ball represents the oxygen atom. The blue ball represents the nitrogen atom. The functional group is C double bond O, C single bond O, C double bond O, single bond N, CON. 2. Isomerism. Isomers are organic compounds that have the same molecular formula but different structural formula. We have three types of, many types, but we'll study in this chapter 3 types of isomers. First type, chain or skeletal isomers, are compounds that have same molecular formula, same functional group, and same functional position of the functional group, but different main carbon chain. For example, CH3, CH2, CH2, CH2OH, and CH3, CH, CH3, CH2OH. In the first isomer, we have carbon chain formed of 4 carbon atom, main carbon chain, and we have hydroxyl group bonded to carbon 1. In the second isomer, we have the main chain formed of 3 carbon atoms, the same functional group, hydroxyl group, and bonded to the same carbon, which is carbon number 1. Then the two compounds have same molecular formula, C4H10O. Same molecular formula, same functional group, same position of the functional group, but different main chain. Then they are skeletal or chain isomers. Second type, positional isomers, are compounds that have the same main carbon chain, same functional group, but different position of the functional group. Example, CH3, CH2, CH2OH, and CH3, CHOH, CH3. In these two isomers, we have same main chain, carbon chain, formed of 3 carbon, and we have same functional group, hydroxyl group belongs to the same family, but in first isomer, the position of the hydroxyl group on carbon 1, and second isomer, the position of hydroxyl group in carbon 2. Then we have different position of the functional group, then they are called positional isomers. Third type, functional isomers, are compounds that have the same molecular formula but different functional groups. Example, CH3, CH2OH, which is an alcohol, and CH3O, CH3, which is an ether, are two functional isomers. They have the same molecular formula, C2H6O for the two isomers, but we have different functional group. In first we have hydroxyl group, in second we have ethyl group. Then they are functional isomers. This is the end of part 1 of chapter 7, functional group.